I'll be demonstrating Solidatus' Snowflake connector. It's actually two separate connectors I'll be demonstrating. One is a connector for pulling policies from the Snowflake public schema, and the other is a connector for pulling metadata from two schemas and deriving lineage from it. So for this demonstration, I'll be connecting to a sample database in our Snowflake environment called COVID-19, and I'll be extracting this information into or from two schemas, CDC and public. So to start with, I'll load the schema policies from Snowflake into a reference model, and this will be the reference model which it will reside. And I'll do this via a connector for extracting the policy information. So I'm going to run that connector right now, and it usually takes somewhere between 6 and 10 seconds to complete. Okay, so now that the policies have been loaded, I'm going to refresh our reference model. And we can see we have pulled in the masking policies and row access policies. These are masking policies, row access here. And in addition to that, we've pulled in what are called tags. And these tags are actually code sets, and they're values that'll be allowable within a given row in a column. If we take a look at this state mask, for example, we can see the actual masking rule over here. And basically what this masking rule is saying is that unless you're an admin, if you try to access this information, you'll only be shown asterisks. Now these policy rules are then related down into the underlying schema, the CDC and the public schema that I mentioned to you earlier. So now I'm going to load those schemas, and for that I'll be using this connector in order to import that, and I'll start running it. This one usually takes 15 to 20 seconds or so to complete. And once that's done, I'll refresh our lineage model, and we'll see that Solidatus has extracted information about the tables and created the relationships from the lineage model to the reference model we created earlier. All right, so this is done now, and let's refresh and take a look at it. Okay, and we can see these relationships have been created, and the indicators here are how we know that. Basically, these are being displayed now because of some rules that I created ahead of time that shows these policies on the model based on the information that we've related from the reference model downward into this lineage model. So we can also see some nice lineage has been created. And if we take a look at this view and I focus on it, then that drills us down further, and we can get a very clear view by eliminating any noise and see exactly where that view is sourcing its information from. So now I would like to show you guys how Solidatus can make this model even better. So remember, the CDC and the public schemas are separate in the Snowflake environment. And we need to create lineage between those separate schemas, the CDC schema and the public schema. When Solidatus extracted the metadata, it also extracted information about the ETL that was used to source data from the CDC schema and push it into the public schema. When Solidatus extracts ETL information, it creates an ID called SolUID. And the great part about SolUID is it allows us to quickly stitch together separate schemas where data flowed between them via ETL. So I'm going to demonstrate that by using our auto mapper. And for this, I'm going to use the SolUID. This auto mapper has a great suite of capabilities. The best one for this happens to be leveraging SolUID. And so now I'm going to generate those mappings, and we can see a whole bunch have been created. And now you can see we've got really nice lineage between our two schemas based on that ETL. So great. So now we can see precisely how the information in the public schema was sourced from the CDC schema. And it's been done with 100% accuracy. And it's really very impressive. So now based on this lineage, we know which fields must contain sensitive information because we can see where the masking policies have been applied. For example, here, I can see that this came from this state code and it's being masked here. So I'm going to turn on a rule that will show us where the sensitive information is in the CDC schema. Now, in addition, I can turn on rules that will warn the user whenever sensitive information has been moved into another table. Okay, so I'm going to turn those rules on. All right, and now we can see here that we're getting a warning that unmasked sensitive data has been pulled into this CDC total beds table. Okay, now this is actually okay though, because of the way the CDC had apparently designed it. So in order to preserve that, what we're going to do is we're going to use this override indicator that I created here. And by flipping that on, now we can see that, yes, we did take sensitive information from the inpatient beds all table on the CDC schema. We pulled it into this table, but that's okay. It was supposed to be that way, so we've overridden it. And now things look good again on our model. But now suppose I were to add another column. Let's say another state column here. I'm going to add it. And let's suppose for a minute that I decided that I would source that information from this table, the CDC inpatient beds all table. You'll notice that Solidatus didn't alert the user that there's a problem. Why? Because Solidatus recognizes this information was taken from a mass source and therefore is not a violation of this policy when it was pulled downstream. However, let's take a look at another case. If I were to source the state information from here, from the CDC total beds table, now this is a little bit of a different case. And Solidatus has recognized this was sourced from a table where the policy had been overridden. And as such, unmasked data has been copied into this table, which is a violation of the intended policy. So to remedy this, users now know the Snowflake schema will need to be updated to apply the masking policy to this new field. So you've seen Solidatus' capability to load policy information into a reference model. We've also extracted metadata and lineage from two Snowflake schemas, and then enhanced the lineage using the SolUID to nicely bridge the two. We then applied a number of new display rules in Solidatus to provide the end user with a much richer set of information upon which to act upon when needed.